Hello everyone and welcome to our new section which is called Queue. With this lecture we begin a brand new section in which we will learn everything about queues. In this section you will get a deep knowledge about queues which includes creation queues based on the arrays and linked lists. And we are going to perform various operations like creation of queue, enqueuing, dequeuing, picking and deleting on these queues. Now in the first lecture let's see what is queue. So let's get started. Now, by definition, a queue is a data structure that stores items in a first in, first out manner. So what does it mean? So to understand this definition very clearly, let's look at a real-life example. So as you would have guessed, the queue is the same as the real-life queue that we see in our daily lives. So here we have a bunch of people over here who formed a queue to buy a new Apple iPhone from the App Store. So the queue data structure is also very similar to the queue that we see over here. So now let's closely observe the common features of this queue over here. So the first feature is that if someone wants to buy an iPhone, he or she has to stay at the end of queue over here. So if some new person comes to this queue over here, he has to stay at the end of this queue over here. So he cannot join the queue from the middle or from the beginning of the queue over here. So when new person comes to this queue, he or she has to stay at the end of this queue over here. So this means that a new addition to this queue happens at the end of the queue. Now the next feature is that a person who is at the beginning of the queue will buy a new iPhone first. So this lady over here will buy the new iPhone first because she came first and stayed in the queue first. So this means that she will be served first. Then after her, the second person will be served and the third person until we reach the end of this queue over here. Now if we summarize these features over here, we can easily see that we are following FIFO method over here, which means that first in, first out. So this means that whoever comes first, she or he will get the iPhone first from the store over here. So in this queue, this lady over here came first and she will get the iPhone first as soon as the store opens, and the second one and the fourth one, and it continues like this. Now if we compare this behavior of real life queue with the queue data structure, we can see that in the queue data structure we also follow FIFO method. So this means that whichever element comes to the queue first goes out first. So let's look at this in the world of computer science. So let's say we have a queue like this. So if we want to insert 40 to this queue over here, we have to insert 40 at the end of this queue. As you see, when we are inserting it, it comes at the end of the queue over here. Now if we continue to add new element to this queue over here, for example, if we want to add 50 over here, we have to add this at the end of this queue over here. So we cannot add this one over here from the beginning of the queue. So whenever we are inserting an element to the queue, it's inserting at the end of the queue. So as we see in the real life queue, whenever new person comes, she or he stays at the end of queue, and here also whenever new elements come, it stays at the end of the queue. Now if we want to take an element out of from this queue over here, we have to start take it from the front of this queue. Now 10 over here came first, so that's why it has to remove first from the queue over here. Then it comes 20, so 20 will be removed, then it comes 30 and it comes 40 and 50 until we reach the end of this queue over here. So this means that the first element that comes served first and the last element that comes will be served last. So hopefully you have understood the concept of queue with this real life example over here. Now let's see why do we need queue data structure. So in case when you need to create an application which utilize first coming data first, then in this case we need to use queue data structure. So as the name of the queue suggests, it is used whenever we need to manage a group of objects in an order in which the first one coming is also gets out first, while others wait for their turn. So you might be interested in which applications we can use queue data structure. Now let's look at the real applications in which we need to use queue data structure. Now the first application is point of sale system of restaurant. It's obvious that the orders must be processed in order they were received. As an order received, it rises to the back of the queue and then it reads order from the front of the queue by cook's device. So whenever we are receiving an order, we are putting it to device and it's inserting at the end of the queue over here. But in the cooker's device, the orders comes from the beginning of the queue over here. So with this, we are processing the orders in order that they were received. So point of sale system in restaurant works using queue data structure. Now let's look at the second example. Now the second example might be printer. Now when we are printing several documents from our computer, printers use queue data structure. First, it has to finish the document that it received first, so it's printing out the first document, then it's going to the second document, then it's going to the third document, and it continues like this. Now with this, printer prints the documents in order that it receives them. Now the third example is, in a real-life scenario, call center phone systems use queue data structure to hold people calling them in an order. So while call center agent is in a call and we cannot answer the call, so it puts all incoming calls in queue. So if you call first, you are going to be first in the queue and waiting while the call center agent becomes eligible. So in this order, they are serving the calls the way that they receive them from the customers. So this makes the work of call center very efficient. So these are the three real-life applications in which we can use queue data structure. So hopefully everything is clear about what is queue data structure and why we need it and in which applications we can use it. So with this, we have come to the end of this lecture. So in this lecture, we have learned what's queue data structure and why we need it. Now in the next lecture, we will look at queue operations. So see you in the next lecture.